welcome to the spotlight session for computer science. Basically, how this is going to go, I'm going to go through a presentation and then we can do like Q&A after. And since it's only you here, you can ask me like whatever you want about the program, about York, campus, anything. But yeah, so I'm just going to do the session first, the presentation, and then we can do Q&A. So a little bit about me. My name is Miriam. I'm a computer science student ambassador here at Lassonde. I'm in my fourth year of computer science. I did co-op as a software engineer for the Ontario government. I did 12 months of co-op with them, like split into different two co-op terms. I also did study abroad in Crete, Greece, which was really fun, and I'll talk more about that later. And a fun fact about me is I've met a Nobel Prize winner. So today's spotlight session, how it's gonna go is we're gonna do like a program overview, and then we're gonna get into like some of the highlights of computer science, and then we'll talk about like co-op and extra sport, extracurricular, stuff like that. Then we can go into like frequently asked questions, and then we'll go into like the Q&A. So the program overview, basically computer science, we focus on both like the theoretical side and the developmental side of computer softwares. So there's also like many opportunities to get hands-on learning experience as well in our program, like whether it be through labs or through project-based learning. And the like a lot of our courses, like some of them, they have like big projects at the end, part of the course, which are a little bit more challenging, but they'll give you something to put in like your portfolio website, on your GitHub, on your resume, which is also really good. Also, it kind of emphasizes like learning by doing rather than just like reading and trying to understand. Like I personally find that really difficult is to just like read or like watch a lecture and then just know how to do it. Like I'm someone that has to get that hands-on experience in order to learn. So like learning by doing, we do have a good emphasis on that in the program. Computer science also focuses on the theoretical side, which for some people, like they're like, oh, but like I don't want to do theory. But it's like it's kind of like you need it, right? Like especially if you want to get into like more complex things. Like a lot of people want to go more into like AI or data, or I'm hearing like more and more people want to do like stuff like quant, like stuff like that. You need like those mathematical background and like the theoretical side of algorithms and stuff like that in order to get into those like fields, like subfields of computer science. So different places you can go. You can be a traditional software developer. You can go into data science. You can go into project management. You can go into product management. So that's more like on the management side of things. And also something that's really big now, and there's a huge emphasis on, is automation and AI. There's a lot of different roles for like automation engineering, automation developers. Like as AI is getting more integrated into different workflows, they need people to integrate AI into those workflows. So that's another like huge like job market, I guess, that you can get into with this program. So some of the degree options, when you applied, or if you haven't applied yet, I'm not sure, but basically we have the Bachelor of Arts, we have the Bachelor of Science, and we have the international degree. So in the Bachelor of Arts, like the difference between these, in the Bachelor of Arts, your degree, you're going to be like, your electives are going to be more like the liberal arts electives. So we're talking like humanities, social science, and natural sciences. But there's also like no additional science courses necessary. So you don't need to like take like, I don't know, like chemistry or physics or whatever. Like you don't need to take any other additional science courses. So this is good for someone if they like struggle with science courses or if they don't have like prerequisite science courses. Like if you didn't take a grade 12 U science credit, you can still get into computer science through the Bachelor of Arts pathway. So it's good for someone like that. And it's also good for someone if let's say you want to like minor in something, like you want to minor in like psychology or like you want to minor in like a liberal arts of some sorts, then this is a good option for you because then you can take all your electives in those social science like courses and you can get that. But if you're someone like you might Bachelor of Science might be better suited for you if you're someone that like doesn't like to write as many essays, if you don't like those liberal arts courses, then maybe this like might be a better fit. So in the Bachelor of Science, you will fulfill a required additional science credits. And there is like a science like prerequisite requirement as well. And in your first year, you'll probably take like one of the three science courses. So like physics, chem, or bio. And then so in the degree, you're gonna have to do roughly around 24 science credits. So this translates into like 8 courses that are science credits. But not to scare you, this is with the honors degree, but not to scare you, a lot of like our math counts as a science credit. So a lot of those credits are covered by the math courses that you're required to take in computer science anyways. So when you take like calculus, it satisfies a science credit. And yeah, and like when you take like linear algebra, like you're gonna take it anyways, and it satisfies a science credit. You're still gonna have to take some credits outside of that, but you can take more math courses if you prefer. Like it's just something I've seen people do. Is they'd prefer to take like a data science course that like qualifies as like a math course, so math course code, and then that still gets them the science credits. So yeah, that's also another option. Then we have the international options. So those are they fold in an additional language course and international oriented courses, as well as an exchange that's typically done in the third year. But there's different options for study abroad. So there's like the international degree pathway, but I'll also talk about some other ways that you could engage in study abroad. Um, so the best thing I will say about computer science at York is that it's a very flexible program. So you can decide to do like minor, double major, and it's like there's a lot of flexibility in the program. So where a lot of like some other places might not have the same flexibility in their computer science programs, like it might be a little bit more rigid. But yeah, so basically you can double major or double minor in like different departments, but I do recommend that you, if you have something like in mind that you like to minor in, let's say like economics, that's like a typical minor, just like search it up real quick to just make sure that you can minor in it because there is a little bit, there's some restrictions. So like over here it says double majoring or double minoring is not possible for iTech, but students may double major or minor within selected programs of AMPD, Environmental Studies, Health, Lausanne School of Engineering, LAPS, or Science, but will need to check the policies for the other programs. So depending on the program, you might be able to take a minor in it or whatever you see fit. So yeah, typically a lot of people I see them do like econ, math, or stats as minors because like yeah, it's like pretty common. And yeah, and we also have an international dual degree option. So after 2 years at York, you could be eligible to spend your third year abroad in the BRSU in Germany in the fall, and then it would be in the University of Crete in the winter. So during that exchange year, the students will take specialized courses and complete a research internship and write an undergraduate thesis. And they will, like, you will receive a dual degree, so a degree of Bachelor of Science from York and also a Bachelor of Science in Informatic from the BRSU in Germany. So some of the highlights of our program. So our curriculum focuses on, it's pretty much like all encompassing, and I will say it's very like choose your own adventure. It's there's not a lot of restrictions, like especially when it comes to like your third, fourth year, like especially your fourth year, there's like no restrictions on like what you can, like what you have to take basically. Except for like certain credits, you need a certain amount of credits in different like buckets, but you can pretty much take whatever you want. So some sample courses are like software design. So that kind of like teaches you how to build like end-to-end applications. We also have like intro to AI. We have applied machine learning. We have computer vision. We have intro to robotics. We also have like embedded systems. We have like, there's a whole lot of stuff. There's a lot of like data courses, like big data, data mining, database systems. Yeah, so it's very like choose your own adventure. Like you can go more on the software side, so you can take all the software design, then software engineering, software testing. Like you go that way. You can go into like the whole AI way, so like do all the AI courses, machine learning, applied machine learning, fundamentals of machine learning. So that the fundamentals one, I think it's a little bit more theoretical, but the applied one is more like project focused. Yeah, you could take like robotics, you could take like more system level courses as well. We even have courses in like quantum computing. We even have like game design courses. So it's really just like you really get to pick what you like and you can go full force into whatever you want to do basically. So some of the technical skills you gain, a lot of people ask me like what languages that they'll learn. Um, Through coursework, it'll be mostly like Java for the most part, and then some courses will also do Python. And if you take any like web dev courses, it'll be JavaScript. And everyone learns C at some point in their degree as well. And then you'll also definitely learn data structures and algorithms because that is very important to our industry. And of course, you'll learn how to build end-to-end applications as well. Another thing that's really important is software design patterns and architecture. So I know that like with AI becoming so popular and companies using it and stuff, some people are scared of like, oh, what's going to happen to like this traditional like software engineer, software developer? Like, how is that role going to change? One thing is like as of right now, it like these AI systems, they cannot build scalable applications, but they should be used and they should be wielded as a tool in order to help in that process. So maybe like the software development has changed from like traditional coding every line from scratch to using AI systems as well. But when it comes down to the building a scalable application, you need good software design patterns and you need good software architecture. So when it comes to like the beginning, the building blocks, like the design of the whole application, you need to figure that out because if you just tell like an AI tool to be like, hey, build this for me, it can build you something that looks nice, but it's not going to actually be like an enterprise level application. Like it's not going to be something that's usable and scalable to that extent. It's good for like prototyping, but it's not good to build that. So software design and architecture is very, very, very important. So another thing that we are asked a lot is how future ready our program is and how we stay ahead. So ways that we do this is like our courses, they, as I said before, they focus on like both the practical project-based learning as well as those theoretical foundations. So you have both. And then you're also able to learn like modern tech stacks and tools that programmers use. So it's not just like we don't like it's not just like writing code on like a paper for your exam. It's also like using like different frameworks like React, like using different front end tools, Next.js, similar to React, Spring Boot. Like these are some things that I learned in my courses. But once again, like I said, it's very because it's so choose your own adventure. Like if you decide not to take those courses, then you don't end up like learning these specific tech stacks, but you'll learn like different ones, right? Depending on what you're doing. We'll also learn to use like a version control system like Git, GitHub, and you'll probably be coding on stuff like VS Code, Eclipse, stuff like that. And another thing that Lassonde does really well is that we have a lot of networking opportunities that are hosted by the co-op department as well as some of our clubs. So every week we get an email and it says like everything that's happening that week or happening in the next couple weeks or so basically. And so as part of that at the bottom of the email, there's always some kind of like co-op department is like running some kind of like event. So it's like BMO networking event or like BMO is hosting, I just brought up BMO, but like TD or like Scotiabank or RBC is coming to do some kind of like presentation. And then you can stay after and you can talk to the people that like came to present. So it's great networking opportunities. And also clubs host a lot of networking opportunities. They do a lot of panels with like previous alumni, like people that have graduated from our university that are now in the workforce and they come back, do a little speech, do a little panel, do a little Q&A session, and then you'll have the opportunity to go and talk to them as much as you see fit. Also, our program is very flexible, which is amazing because you're able to basically choose your amount of course load. Why is this good? You might decide that, hey, taking the traditional like 5 courses a semester, like 5 and 5, I don't do well like that. Maybe I want to take 3 courses in fall, 3 courses in winter, and then take the other 2 in the summer. You could do that. So it's very like you have a lot of opportunity to kind of like be really flexible with your degree. Of course, you want to still stay within if you're like receiving like funding, like OSAP, stuff like that. Like you still want to stay a full-time student. But you do have the option to take like summer school. You do have the option to kind of like play around with your course load. What this is great for, though, like the highlight of this, is applying to internships. So typically, summer internship applications are very, very, very competitive, and fall and winter, the competition drops like that. So if you're able to land like a fall or a winter co-op term or an internship, that is so much more beneficial because like you're also able to, because our course load is very like flexible, you're able to take a term off in your studies, like to not work, to not study, let's say in fall or winter, and instead do your co-op or your internship in fall and winter instead of summer, because that way you're, especially when it comes to like landing your first internship or your first co-op and you don't have a lot of experience, the competition is far lower for fall and winter co-op terms. So I do really recommend to do that. So more into co-op and extra support, kind of already started talking about it. So how does co-op work? It starts after your second year. There's some like required courses and stuff like that that you would uh basically need to take in order before your first co-op term that are like second year courses. So once you complete those, you can start your co-op terms. So co-op terms are roughly around 4, 8, 12, or 16 months long. So they come in like fours basically, just like typical to an academic term, right? So that's how it usually works. The co-op department provides us, I often get questions about like how does co-op support you? So the co-op department does like provide us with resume building workshops, cover letter help, and interviewing workshops as well. And they also do like mock interviews. So I remember when I had my first interview scheduled through the co-op portal, I even got a call from my co-op coordinator being like, "Hey, I see you have your first interview scheduled. Do you want to do a mock interview?" Like she called me, like my phone, because we put in our phone number to like so like my co-op coordinator did really reach out and did really help me in that process. So I am really grateful for that. So that's what I mean by like our co-op department does help us. But with that being said, if you're not applying to co-ops and you don't get a co-op, if you apply to like 2, 3 co-ops and you don't get a co-op, you can't blame like the co-op department. Like you have to be applying to everything on the co-op portal, off the co-op portal, on LinkedIn, on company job sites, stuff like that, right? Like you have to be on top of it. Also, we typically get asked about salary ranges. The thing is, it's a really broad range depending on the year of your study and the employer. So salary ranges can be anywhere from like 20 to $50 per hour. So like if it's like a really small company that's like maybe like a startup with like I don't know, like 4 or 5 people, obviously they don't have a strong budget, so maybe the pay might be lower. Typically like government roles, the pay isn't like as competitive as let's say the banks. The banks typically pay like a little bit more. So yeah, so it really depends. So I would say it's more so typically like out of what I've seen with my friends, 25-ish to like $35 an hour is the range. On the higher end, we're talking about like the bigger tech companies, IBM, Amazon. My friend was able to get an internship at Tesla, and that was in the States. So she moved down to Austin, Texas, and I have a little picture of us there because I went to go visit her. And yeah, so like she gets paid obviously a lot more per hour there. And yeah, so that's why the salary range here is like really big. So it's really there is a huge range. I will say expectations though around like 24 to 35 is typical. And yeah, and it's great to do co-op or even if you don't end up doing co-op through the co-op program, I do really recommend you do an internship because you must get hands-on experience before you enter the workforce, before you graduate. It's really important, especially like in the current job market. But yeah, so some of our top employers are like IBM, Amazon, RBC, TD, and the government on Ontario. I wrote government of Ontario because that's where I worked, but and a lot of people I know, there's a lot of recruitment in for government roles, and they specifically look for like York University is one of like their biggest like I guess partner universities. So yeah. And then I have a little picture of me and my group member from our capstone project at TD. So TD does do a lot of partnerships with York as well. And I have a couple of friends that also did their co-op terms at TD Bank. Also, RBC is a very common employer as well. So, other opportunities that are available to you beyond just the classroom, we have research opportunities. So, the best thing is, not only do we have research opportunities, we have funded research opportunities, which is great. So, like the USRA NSERC LAURA program, that's like your typical like award-based funding. So, that's like scholarship type style funding. Yeah, so basically, it can change depending on the year, but this year it's $10,000 for the summer. So it's kind of like an internship. So you work full time. It's like based on 35 hours per week, and you work in a lab at York, and you get funded, you get paid. It's like an internship. So you get, yeah. There's also Ray, which is a little bit more dependent on the like the lab that you're working with, and like your hours are I guess more flexible in the sense of like you get to like choose your, I'm not sure if like you agree with your professor on the hours. So it's not like in the way where it's like a structured award based system. It's more of like a kind of like a research job. Anyways, so we have different research labs. We have a computer vision lab. We have a neural computing for machine learning lab. We have the data and AI lab. We have a human computer interaction lab. Those are just some examples. There's so many labs, so many labs. If I were to write all of them, it wouldn't even fit on the screen. But yeah, there's also opportunity to complete research through the research courses. So you would get like credits for that research. We also have like capstone where you're able to do research, and I have a little picture of myself. Uh I presented our capstone project. So you're for our capstone project, we partnered with TD. So we went to like their downtown office. We built a software for them, and we presented it on capstone day in typical like research style presentation format, basically poster presentation conference style. But yeah, but basically that's another way to get like experience like that. And the good thing about capstone is that like you're partnered with an industry organization, so it's another thing to add onto your resume. Like I get to say I worked with TD on my resume, right, which is pretty cool. We also have a lot of extracurricular activities. So there's a lot of different clubs. There's a lot of different like computer science oriented clubs like CS Hub. There's like Women in Computer Science and Engineering. There's Game Development Club. There's AI in Healthcare. There's a bunch of clubs. There's also clubs that are like unrelated to computer science. There's so many. There's literally so many. Like anything, any interest that you might have, it probably exists. There's like a taekwondo club. There's like a bubble tea club or like a boba club. They literally just go and like try different bubble tea spots together, which is like pretty cool. There's literally any club you can think of probably exists. And if it doesn't, you can make it. You can create it because I've seen so many of my friends have made clubs while being at York. So yeah. We also our clubs get funding to do like fun things, so which is also nice to like host events and stuff like that. And even if you don't join a club as like a member, you can always like just go to the club events. Like that's something I did throughout. I wasn't like a regular member of any of these clubs, but like I just would attend their events because they're fun and there's usually food involved. There's also, we have design teams. So we have Blueprint, which basically what they do is they do things like build software and like um, stuff like that for like nonprofits, like build software, build them a little like website or like whatever for different like nonprofit organizations that like can't afford to basically hire a software engineer. So it's like this partnership where they're able to like build things and help out the community. which is great. And then we also have a robotics club. They go to like competitions and stuff with like, and they compete with their rovers, stuff like that. There's like a rocketry club, which also is like really cool. They like build a rocket and then they go to like these competitions and they shoot their rockets in the sky. We also have a lot of hackathons that are hosted at York. So there's one Control Hack Delete, and then there's one LHACS. LHACS is like a women only hackathon. So it's like to encourage like women in computer science, basically. And there's also study abroad. So you have the chance to study in like different countries. So that's how I did it, my study abroad opportunity. But yeah, so like earlier I talked about like the international dual degree option. I talk about the international bachelor of science option. There's like those are options, but you could also just do it like way more casually, just take a course abroad. Like that's what I did. Took one class. I went to Crete, Greece, but some of my friends, they've done the same thing and they went to like Germany. They went to another one of my friends went to like South Korea. So yeah, so you can earn credits and you can also, there's a lot of like funding opportunities for that, like a lot of different like scholarships and awards that help you fund those opportunities. But yeah, so we also have student support and resources available. So we have peer tutoring. It's offered to help students excel in courses like math and sciences, and it's completely free. There's multiple drop-in sessions a week, both online and in person. So I use this in first year, like for calculus. I literally just you just show up and there's students there and they're there to help you and it's completely free, which is a great resource. Especially like in your first year when you're like still trying to like kind of adapt to the university lifestyle and the pace of everything. It's a really amazing resource. I do recommend you use it. We also have student accessibility, so they provide students with services such as learning accommodations and note taking and remote learning requests and other accessibility needs, basically. So, a couple frequently asked questions. What is the difference between computer science, computer, and software engineering? So, the biggest difference, I would say computer engineering is a bit different because it has a more emphasis on hardware components of the computer. So we're talking like the CPU, the GPU, I don't know. Anyways, all those hardware components, how they interact. They also do have, like, they do learn software as well. Like, they do learn to code as part of their degree, but that's like where it differentiates. Like, we don't focus as much on the different components and how like they work, and like we don't look at like the motherboard and like plates thing. Like, no, like we don't really do that. That's more of a computer engineer's job. And yeah, and then a software engineer focuses more on software design, whereas computer science, like both of us, like both computer science and software engineering, have that emphasis on the software side of things. Where it differentiates is in your fourth year, software engineers have to take specific software courses. So that's like advanced software engineering, software design. I think they have to take software testing, software requirements. Those are like they have to take those. Whereas computer science, like you can kind of take whatever in your fourth year. So it's not like as I would say like strict in the curriculum. At the end of the day, the jobs are the same. Like at the end of the day, the three of them typically lead to the same career path, which is like software development, software engineering. But with the exception of like computer engineering, they can be on hardware side as well. And computer science, because it's only a 4 year degree, whereas engineering programs are typically a 5 year degree. It's also a lot more flexible. So you get to take like the courses that you like. There's also opportunity, like with that being said, to take more like theoretical courses, but both programs can take each other's courses. We just have more flexibility to take the software courses and let's say AI, machine learning, whatever, right? So what made me choose Lassonde for me when I was looking for what program to go into, something really important was co-op because you want to get that industry experience while you're in university before you graduate because it's gonna make it a lot more difficult for you to find a job if you don't have any prior experience before graduating. So co-op was a big factor for me. And Lassonde does have a pretty good co-op program. We have a lot of like organizations that come to us, and we have a lot of support. So yeah, for me, it was mostly co-op. And I'm also happy I chose it because the community, I will say, Lassonde, like we're not that competitive. We do help each other out. Like my friends will literally text me like, "Oh, Pinterest internship applications just dropped. Like, go apply." We're literally competing for the same jobs. Like she's also applying, I'm applying, but she'll text me and be like, "Hey, like they dropped them. Like go apply." Because we're not really that competitive. Like we're kind of more of a community and we want to like help each other out. So I will say that's like another reason to join Lassonde. How can you tell if this program is the right fit for you? I would say if you're like a really big into problem solving, that's how you know this program is right for you. If you're an analytical thinker and you're also creative. Like for me, it was always like, do you like to build things? Because I always loved building things. Like growing up, I always like was the like always had little projects, like little things that I would be building. So this is a way to build things, but not as like physical. You're building things through software, through code. So I will say like that's like a great indication that you would thrive in this program. Also, if you have strong math foundations and you kind of want to take a program that's like mathy but like more applied, I would say this is also a great program for you. How has Wait, what? What has been a highlight of your time at Lassonde so far? So for me, I would say a highlight for me was probably is a little bit of a cheat, I guess. I would say it would be study abroad. Technically, that wasn't at Lassonde, but that was a really, really fun experience, and I do recommend that you apply if you get the chance. Um, but yeah, like you're never gonna be young in Greece with a bunch of other young people like living life basically or like wherever you choose to go. Like my friend did one in Japan, like, and everyone has like amazing stories to tell from their experiences. Anyways, with that aside, because that's technically not at Lassonde, that was in another country, but we also have a lot of hackathons that are hosted, and I do really recommend you join hackathons. I remember my first hackathon was L Hacks, and I like went in like not really knowing that many people, but then I like made friends, and it ended up because it's a whole weekend long, and you end up like working on a project. So you end up pretty sleep deprived, and you end up like bonding with these people while you're sleep deprived. And it's just a fun experience. Like it's really, really fun. I recommend you do as many hackathons as you can. As many weekends as you have available, do hackathons. They're so much fun. They're literally so much fun, and you should really do them. Do you have any advice or tips for someone starting the program? Yeah, do hackathons. But other than that, I would say build your math foundations. And I don't mean to scare you when I say like build your math foundations, but like obviously like if you're someone that struggles in math, you do need to like build those foundations because it's just going to build on top of those. But if you're like doing okay, then you're probably going to be fine. Also stay curious and just stay curious and start building things earlier on. So like start off by like watching YouTube tutorials on like building different software and like follow along the YouTube tutorials. Then you'll learn how to code based on those and like start like adding to that. Let's say like you watch a YouTube video on making, I don't know, a website that's like for a restaurant, like a menu website. Then start like editing it and make it something really specific. Anyways, yeah. So we can move on to the Ask Me Anything portion, but I think let me check the Q&A. Okay, I do have questions here. Okay. Okay. So I'm gonna should I do these while I okay, we can do some of them now and then I'll okay. What is the overall employment rate for recent graduates and which industries or sectors are hiring them most frequently? Ooh, okay. So I don't have an exact like statistic about our employment rate for recent graduates, but I will say like personally, I'm in fourth year, right? Like so I know a lot of people that are graduating or have graduated and stuff like that. Um, Most industries that are common is I feel like banking. A lot of my peers have gone into banking, like RBC, Scotiabank, TD, BMO. Like these are like where I've seen like a lot of like people that were like a year above me that have graduated are working in mostly the banking sector. But like in obviously software roles, so like software developer or data analyst or stuff like that. Product management. One of my friends is working in product management. I don't have an exact employment rate though. I don't have a statistic, but I could bring it up to like the recruitment office to maybe get a statistic if that's something people are interested in, because I guess that would be obviously very interesting to know as someone starting out. Um, but yeah, so I would say like that's the most common. Okay, specifically, what percentage of graduates are securing roles in emerging fields like generative AI and agentic AI? Listen, I don't have stats, but I'm not exactly sure how many, like what percentage are securing roles in those fields. I will say though, when it comes to like the AI realm of things, a lot of times industry is looking for like graduate level, like more research level things. Why? Because it's something that's very new and it's something that's very, once again, like theoretical that turned into applicable, right? So a lot of like I've personally applied to a lot of different AI roles, and in those roles, like in the interviews that like what I was asked was very like research heavy topics. um so yeah, so a lot of those roles also in the job postings, like you can see like a lot of those roles require some kind of level of graduate school, which is yeah, like a lot of those roles like you'll see like it'll be like AI engineer or something or machine learning intern or whatever. It'll be like in a master's degree or PhD, master's or PhD. Not to say all of them are, but that is very common. Agentic AI is a little bit different because that goes more into like the automation side of things. Automation is something you can do with just an undergrad. So like I feel like what's happened, like I personally did a little bit in automation as well. It's like what's happened is the shift. So it used to be like building bots basically with like traditional code, but now it's like shifted into like agentic AI, like using different like AI agent tools to do that instead of building just a bot that does it every single time, basically. So yeah, so that you could probably get into with just an undergrad. But once again, like what percentage, I have no idea the percentage of students that go into those roles. But yeah, I do know a couple people that work in those like that industry and like the AI side of things. One of my friends works at Pinterest for in like their AI team there, and another one works in like TD, their like research department. But both of those people have master's degrees. So yeah, if that answers a part of your question, I hope. Beyond immediate employment, what are the most common paths for your alumni, such as graduate school, research, yeah, or entrepreneurship? Yeah, so we have like basically I'm doing Laura this summer, which is like our research award summer internship thing. But that's like a really common for students to do that basically. And that kind of feeds into like graduate school in the sense that like you're able to once get that research experience to develop that relationship with the prof, like become, really close with the prof. You're working on that research with them. And typically, when you land a role like that, the prof has taken an interest in you to basically like pay you for that summer. So you can go to them for like graduate school basically. Because for a graduate school, like if you decide to do a research-based graduate program, you would need to develop that relationship with a professor before basically trying to, like they need to be your supervisor, right? Like you need a supervisor for research-based master's programs. So yeah. So entrepreneurship is also common. We have this thing called Y Space. So basically they help out like build like different entrepreneurship help like your students basically build and like provide them with mentorship, provide them with different resources. So our capstone project, we actually got reached out by Y Space. Like they were like, hey, your project has a lot of potential. If you guys need help in like turning this into a startup idea, or like, you want to kind of like move it forward, you can. So there is that. We had like a group that there is a startup that started at York. Basically, they do like 3D printing for like industry. And it started at York and it's actually like pretty big now. And they're one of the employers for like York students, like coming out of York, like alumni will go there. And it was started by a bunch of York students like while they were at Lassonde. So that's like another example. Also like the research departments, like the lab that I'm working with, the data and AI lab, it is in partnership with like they do a lot of research in partnership with IBM and in partnership with AT&T labs. So these are like industry partners that are also interested in research. So you get like that kind of graduate experience of like the research role but partnered with an industry. So the labs are better funded. They're also doing like amazing work. And like my professor, like his past like master's students have gone to places like IBM, like has hired them straight from the lab. And Amazon, like AWS, a lot of them go there. And one of his past students ended up at Google. So yeah, it's not common. It's not, but it's also not like unheard of, you know? So yeah. So it's like if you really try your best, you can get to places like that. But I will say most common employers are like the banks. What unique skills or experiences distinguish your most successful graduates from the rest of the cohort? Oh, I will say, um, being like curious and like just being like a go-getter. So like I will say like this is just like an observation that I've made from the people I know that have gotten those like big tech roles that have like gotten to go to like the States or whatever, right? Like to like these like really massive tech companies. What they have is they like it's kind of a numbers game. They're applying to everything and anything that comes out. Nothing is like too impossible. Like you apply to everything. And we're talking you apply you're constantly applying to every single internship that there is, basically. Like you're constant, it never stops. Like you're applying always, always. It's an application cycle every single day. You're not like waiting, oh, I'm going to apply for summer, I'm going to do summer term. No, no, no. They're like constantly applying all the time. And they're interviewing a lot, and sometimes it sticks and sometimes it doesn't. So I will say like that's like the biggest thing. It's confidence, it's knowing how to speak properly because it's one thing to get an interview, it's another thing to pass the interview. So like being personable, making those connections, doing coffee chats. Like my friend that ended up at Tesla, like she did a lot of coffee chats, which she didn't get like she didn't get her job through coffee chats, but I think those coffee chats established like her way of speaking professionally, of showing that like even if she doesn't know something, kind of being able to not really fake it, but like being able to appear confident enough that she can figure it out, even if she doesn't know it, like she's able to figure it out. But yeah, so like that's like I would say like I would say the biggest thing is like one, like communication is really big because especially nowadays in like the age of AI, like syntax doesn't matter. Like it doesn't matter as much, right? Like you can search up syntax really easily. Like you can figure that out. But it's about how you speak, how are you able to communicate? Like you have to be personable, stuff like that. But yeah. So I'm gonna move on to the kind of the closing of the session. So we have different opportunities to join the Lassonde community. We have like weekly Lassonde tours. We have spotlight sessions like this for different programs as well, if you're also interested. We have Ask Me Anything drop-in sessions, and we have a podcast as well. So you can connect with the Lassonde community through Discord, where all our ambassadors are on there and basically there to help answer any questions. You can stay up to date for new and ongoing events, and you get real answers to tough questions from the best resources ourselves. And you could do one-on-one chats with current and future students, admissions experts, and those who can assist you with your application experiences. So thank you for joining the session. I'm going to stay back in case you have any additional questions, but I'm going to like wrap up the session in terms of the recording. But yeah, so thank you so much for joining our session. here's the link to future events, and here's our email address.